Hello guys, welcome to Unified Science Lab. Today we'll be solving questions on differential equation solution. Then you say here A. Let me put in writings here. Y squared will be equal to like you this 4x times 4a times x rather. That will be 4ax plus 4a times a. That will be 4a squared. So 2, we differentiate this xy, that will be 2y, 2y dy dx. That's the differentiation of this dx. Then you differentiate this also. Remember, a is constant, is equals to 4a with respect to x, that's 4a, plus differentiate this, that will be 1, and here will be 0. Because this is constant, there's no x. A here is constant, there's no x to reach, so we move on. Differentiate it again. Differentiating this again, that will be y dy dx is equals to sorry, not differentiating, dividing this through by 2. Divide this through by 2. This goes into this 2, this goes into this, into a. We don't have to differentiate it again. So moving forward, we now know that a, bring a to this side, then bring this one to this side. A will be equals to y divided by this y divided by 2 times this y dx dy dx. Or if you don't want to write it like this, you may write it like this, or you write it like this, y dy dx, or to see the same thing. But I prefer using this one. I prefer writing it this way. So moving forward, we say that y squared is equals to 4. Like we go back to the first equation. Okay, let me say this is equation 1. We go back to the first equation 1. Understand? Going back to the first equation, that will be 4x. See, since a, this is a, any place you see a, impute. So x, this is a, you impute y over 2, y over 2 times dy over dx plus, remember the equation that we are using, 4 y over 2 times dy over dx. And don't forget to put your square because square was here. Then moving forward, we have here y squared equals to, how do you, okay, let me write it first, 2x y dy over dx plus 4y squared over 4 dy over dx squared. Please don't forget to put your squared. So I wanted to write it out first before I come back and explain it. So from here we get here. How do we get here? This 2 cancel this 2. That's why we have here 2x. The y comes in y, like removing the bracket. This 2 cancel this 4. 4 into 2 into 4, that will be 2. And then coming here plus, the squared here. This times this give you this times y. This squared will come to y, and 2 squared will be is 4. You understand? And this one, because there's a multiplication sign, you do them separately. They are not together. Do them separately. Then doing this one also, you have, if you want to do this, okay, let me do just this one. Dy over dx squared. If you want to, yeah, I see the same. There's no need of long solving. They just bring it down here. This is it. And note, this one is different from this one. Y squared over 4 is different from dy over dx. Then put them in bracket squared. It's very different thing. Like, it's very different thing. Then we move on from this place. which that will be y squared is equals to 2x y dy dx plus y squared. Then in bracket, you bring in the dy over dx squared. Here, there is a here also the how we got this y squared. You know, this one is still the same. This one was not there. I was just trying to explain something. This one was not there. So how to this one is still the same here. You brought them down here. So we were trying to solve this other side. You know, this other side was this. You understand? Then this 4 cancel this 4. 4 is gone. So the y squared comes in here. Then you bring in back this one. You understand? Bring down this one. The y squared comes in first. Then you bring this one. Then we move forward. That will be the going to like bring this one to this side because you equate everything to 0. That will be the squared first. Y squared dy over dx squared plus 2 xy dy dx. Why the equal this sign in front of them have not changed? Because they have not crossed this the equality sign. It's only this y that crosses the equality sign that will change to minus y squared. Understand? And the y here, yeah, that's the only thing that will change to minus. Let me not go further because I have other example that I will do, and you understand more when I start doing other examples under this. I will do up to 3 more or 2 more examples. So we have then equals to 0. This is the answer to the questions. Then let's solve another example. Example 2, number 2. So moving forward to solve another example, we have the example 2 that I would like us to solve is formulate the differential equation from y is equals to a exponential 3x, like 3 raised to power 3x plus b exponential x. So we start by differentiating them. So differentiating y will give you dy dx. Then you put equals to differentiate a exponential 3x, and that will give you 3ax. So let me write them down. Differentiating y to give you dy over dx equals to, this is x, sorry for my the way I wrote it, a exponential 3x. Remember, anytime you are differentiating something that has exponential, the number still remains the same. If it was another thing, like there was no exponential and this x was not there, the number would have changed. You understand? So we move on. Differentiate this one also, it still remain the same. Nothing changes because it's only one, and the one comes is still the same. 1 times 1 is 1. So b plus b exponential x, that one still stay the same. Nothing changes. So from there you move on to saying from equation 1 we have b, this b here, b exponential x will be equals to this one. Nothing crosses, it's only this one that will cross to this other side. It's only this one that will cross to this other side. That will be y. When it crosses the equality sign, it turns to minus a exponential 3x. So I like to call this one equation 3. This one will be a little bit longer than the last one that we saw. Then after writing that, we go down by saying dy over dx equals to 3a. That's this one. Anywhere you see b exponential x, you impute this value. That's what we are going to do in this step. 3, bringing in this one again, 3a exponential 3x plus, anywhere you see b exponential x, bring in this, because b exponential x is equals to this according to from the equation 1 that we had. So we have, then you put in brackets for normal identification of it. 3x. You move forward saying the dy over dx equals to y plus 2a exponential 3x. You call this equation 4. And some people may be wondering, how do we get this y plus 2x 2a exponential 3x? How we get this? Got this because y is already here. You understand? How we got this is this y as it goes with positive sign, and this one is with negative sign. So this is 3a exponential 3x. This one and this one side is the same. So this is 3, this is 1. So 3 minus 1, it gives you positive 2a exponential 3x. That's how we get there. 3 minus 1, these values, these things are the same here. So 3 minus 1 gives you positive 2. That's how we get there. So dy squared dy squared is equal all over dx squared. Like, we want to differentiate the second time. This is the one that we are differentiating the second time. Dy over, we differentiate this y. You understand? Differentiating y will give you dy over dx. Then differentiating this 3 times 2. Let me rush through it. But I'm doing the correct thing. I'm very sure of that. Oh, my calculator yourself. Let's rush through it. That will be 2, 2, 3, 6, 6a exponential 3x. Don't forget this value up here will not change. Let name is equation 5. Am I too fast? Okay, let me slow down this one. So from equation 4, this is the equation 4. From this equation 4, equation 4, we have that 2a exponential 3x is equals to dy over dx minus y. 2x exponential this. It's only this y that crosses the equality sign to this one. When making the subject of the formula, anything that was with this one, you make it to cross the equality sign to the other side so that you can, this one can stand alone, making this one the subject of the formula. So you just make this the subject of the formula. So y was with this other side with what was at this other side with this. So we take it to this other side, crossing the equality sign is changed to minus. Understand? Making it equation 6. I'm giving this equation so that you understand the steps very well, how we are going about it. So after knowing that the 2a exponential 3x, this is 3x is equals to dy dx. So we bring in this so that we can impute some things. Dy over dx is equals to dy dx plus 3 to a exponential 3x. You may not understand and you may ask, why is 3 here? Why is 3 coming in here? Yes, 3 comes in because from here we have 6 and here is 3 and here is 2. 2 times 3 is 6. Then it goes back to this. 2, 3, 6. It goes back to this. And this one is here. Everything is okay. They are still the same. Then we just wanted to have this to be equal to this. Then moving forward, we have let me just write it in a like in a statement. So doing that, we will have here dy squared dx squared equals to dy over dx plus 3 dy dx minus y, because 2a exponential 3x was equals to this. That's why we bring it into the bracket. Should I jump? No, I don't have to jump a step. Let me just do it step by step so that you understand everything. Over dx squared equals to dy over dx plus, removing them from the bracket, you will have 3 dy over dx minus 3y. 3 times this gives this, 3 times y, it gives you this. So we move forward saying dy squared over dx squared will be equals to this plus this is 1, this is 3. 3 plus 1, that will give us 4 dy dx minus 3y. So our final answer will be, you create everything to 0. Our final answer will be dy squared dx squared. This should be minus because this crosses equality times to this other side. This one is on its own, and this other two, the sign will change because it crosses equality sign to this other side. That will be minus 4 dy over dx plus 3y is equals to 0. So that's the answer to this question number 2. That's the answer to question number 2. So moving forward, I would like us to solve another one more example. I'd like us to solve one other example. So this is the next question I would like us to solve. Formulate which is the equation, the third question that we are going to solve now, which is formulate the differential equation from y is equals to a exponential minus 3x plus b exponential 4x. So that's equation 1. So differentiating them, you will have differentiating y. Remember in the first and the second one, we differentiate y. So you're supposed to know the differentiation of y by now, which is this is equals to differentiate minus 3x. That will give you minus 3. Remember the x is constant, you don't have to write it. Exponential minus 3x, and plus you differentiate this, you have 4b exponential 4x. I like to call this equation 2. Then moving forward, we have, let's take from this equation 1. Remember how we solved the number 2 question? We apply that same formula, the same way, the same pattern to this the equation 3, saying from equation 1, a exponential minus 3x is equals to y. Here y does not cross the equality sign, is the second one, which is this b exponential 4 crosses the equality sign. That's why it changes from plus to minus, and I would like to call that equation 3. So moving forward, we have dy dx like this one. Dx equals to, anywhere you see a exponential minus 3x, you impute y minus this. So we move forward, say minus 3 we have here exponential, then you have to put them in bracket for proper understanding. You all will not make mistake while solving it. 4x, then moving forward, plus 4b exponential 4x. So we try to remove this from the bracket. Removing this from the bracket, you have dy over dx a is equals to minus 3y plus plus 3b exponential 4x plus this, which is 4b exponential 4x. Then let's differentiate it. Differentiating it the second time, we have to differentiate this for the second time, and we will have y. No, before we differentiate this for the second time, let's break it down to its last part, where it will be where this plus this, because this and this are the same. If it's not, we would have differentiated the second time. Since they are the same, let's just add them together before differentiating it the second time. So dy over dx equals to minus 3y. They are the same, plus 3 plus 4, that will give us 7b exponential 4x. I would like to call this equation which equation? This is number 3, this is equation 4. So moving forward, we differentiate it the second time. The y squared dx squared is equals to, differentiating this the second time, you know how to differentiate the that will gives us minus 3. Differentiating y, you have the y over the x. So moving forward, you did plus 4 differentiating. 4 would have come here, so 4 times 7, 4, 7, that will be 28 b exponential 4x. I like to call this equation 5. From equation 4, you have 7, this 7 here, 7b exponential 4x is equals to dy, this dy over the x. Remember, the equality sign will change because it's called this sign in front of it will change because of it crosses the equality sign. This will be the dy over the x plus 3 y. Then we call this equation 6. I think that will be the last equation. We are getting to the final answer very soon. It's nothing much anymore. So we substitute equation 6 into equation 5. Substituting this equation 6 into equation 5 means anywhere you see 7b exponential 4x, you impute this value, and you can see here, you note that this place, the 4, like 7, what will make this, that will be 4 times 7 will make 28. So you bring 4 outside, and so that 7, you'll be able, bring it 4 outside, you'll be able to have 7b exponential 4x in this place. You understand? The way we did in the last example, that was example 2. So you have the y squared over the x squared is equals to minus 3 dy over the x, this minus 3 here, plus, remember what I told you here, 4 times 7 will give you 28. Then we bring in this. I'm doing it so that we can have this one. Understand? B exponential 4x. Knowing that this is equals to this, we will go back and do the solvings again. Dy, it's nothing much. The x, we are almost there, equals to minus 3 dy over the x plus 4. This equals to this 4 dy over the x plus 3y, and then we get to the final answer without wasting much of our time. Okay, let me remove them from the bracket first so that you will not make you to be confused while solving an example under this, or in example you'll be able to remember how I get to pass that step. 3 minus 3 dy over dx, and plus, removing them from bracket, you have 4 dy over dx plus 4 times 3, it gives you 12. 4 3 12, very simple calculation, 12y. Then you know that you have already, oh sorry, there's no need of this bracket again, you have already removed them from the bracket. So you get to the final answer, which will give you dy squared and over dx squared equals to dy dx plus 12y. And some people may be wondering, how? This is 3, this is 4. Dy dx, they have the same, they are the same. So 4 minus 3, or you do minus 3 plus 4, still gives you 1. 1 is here, so you don't need to put that one. You know, in mathematics you don't need to put that one. So that's how you get there. This 2 is this, then you bring in this one. That's the final answer for the question here. Then moving on to the last question that I would like to solve for today, or for this video, and that will be number 4. So solving the fourth one, you can see it's kind of different. There's this one, we have trigonometrics inside, the cos and the sine just comes in. So we are going to just solve it very well. You know how to differentiate sine and how to differentiate cos. So this is the last question that we are going to do under this. So let's go into solving. I would like to write solution, but because of time, you know, we have spent enough time on this particular video. So let's just make this equation 1. Then moving forward, let's just separate everything so that you'll be able to differentiate it very well. So let's u here is equals to log x. Understand? Let u be equals to log x. So u is equals to log x, and the u will be equals to 1 over x. The x we move by saying y is equals to a cos u plus b sine u. Don't forget, this is u is log x. Understand? I just want to minimize everything. That's why I say let u is equals to log x. So you see, call this equation 2. Moving forward, we have we differentiate them. You know what? How to differentiate cos, how to differentiate sine. So differentiating y first, you have the y over the x. Then you differentiate cos. Differentiating cos will give you minus sine. So you need to bring the minus sign outside. Sine u plus differentiating sine will give you positive cos, which is still the same. The sign will not change here. U. So and we would like to move forward by bringing in this sorry, this one was du because we are using u. Sorry, this one was du, not x. It was du. Understand? So we solve for the y, just the y only, and you have this equals to, because of the d that comes in, you have here a sine. Please take time and watch the video so that you understand. If you just rush over it, I do the normal solving, everything. Just take your time and watch it very well. Go through it. Any one that you don't understand, yeah, feel free to ask a question in the comment section. So that will be equals to minus sine. Remember, u is equals to log x, and the u is equals to 1 over x dx. So we will have sine that, bring the log in, log x 1 over x dx plus b cos log x 1 over x dx. So the y dx here, this is where we get y dx. The other one was the y du. The y dx here will be equals to a sine and log x. You know, there some people may be confused here. Why do I divide it by x plus b? I'm going to explain that. The log x over x. Why I divide it by x is because of this 1 over x that is given here. You know, the x differentiating this, you have this different, like this is gone. That's why it's been given like this. So sine, oh, I forgot to put a here. So this comes down here. That's why we have divided by this. This is still the same as this 1 over this. You understand? No, nothing is different there. So dy dx will be equal to, I told you it's the same. So okay, let me just put it in bracket so that you know that it's the same. 1 over x will give you minus a sine log x plus b cos log x. It's not 10, no, it's log x. Then it grows the bigger bracket. You see the same. This one was the same thing that we had here. So we have to bring this one aside for a clearer understanding. X, like bringing this x to this other side. I mean, or we can say x. Some people will be confused here. If I just okay, I'll explain. Let me just write it first. I'll explain. Dx equals to minus a sine log x plus b cos log x. Let's name this equation. Is it 3 or 4? It's question 3, but let me just leave it there. Okay, how we have this x here and the x just disappear from here is that we multiply through by x. Multiplying this by x gives us x, and they bring in this. Multiplying this by x, this place will be x. You understand? This place will be x. So x will divide this x. That's why we don't have x again this other side of the equation. So the x was not here, so that's why it's been this multiplication sign multiplied by this x multiplied by this. So that's how you get to that place. So and before we get to the final answer, there's one rule that we use, which is product rule. I know many people know product rule now. If you don't know it, I'll drop a video on my channel. You can go and watch there how to do product rule to solve equation using product rule. Also differentiate using product rule. This one will just go straight to the point. My channel is there to guide you to in this your academic session. And a cos log x divided by x. The one that he had is the same thing. Yeah, it's the same thing using product rule. Minus b sine log x over x. So moving forward, we will have x. If you don't know how to do this product rule, there will be a video on my channel on how to solve the product rule. A video about product rule on my channel. There's a video there. So just go to my channel and watch the video. Log x plus b sine log x. Then moving forward, we have x dy over dx with plus dy over dx is equals to minus 1 over x times y. Why do I say times y? Because if you come over to the up here, you see that y is equals to this. So you can even replace this by y. This u, remember this u is log x, which is here. It's either you put u or you put log x here. So y is equals to this. So you can interchange them. Understand? So moving forward, we have x dy over dx is equals to y. And how do we end up having this? Remember, x was here before. We did not have x here, and minus 1 over x was here. So how do we get there? The way we get there is that we multiply it by x. We multiply through by x so that we'll be able to eliminate this other x here, this other minus x here. We don't need it. That's why you just multiply it by x. So x times x will give you x squared, which is here, and this one there was no x, and we bring in x there, is equals to y. So, and getting to our final answer, we have x squared dy squared dx squared plus x dy over dx equals to, oh, now we plus because it was minus here. So this minus here affect this y. It was minus y here. It was to minus y. It was minus y because After the x being cancelled, this x, the minus sign is still here. So minus times this, minus 1 times y is still minus. So this will be minus, plus rather, after crossing the equality sign, because it crosses this equality sign, it will turn to plus y is equal to 0. So this is the answer to this other question.